Hey guys, thanks for joining me. Today we're going to take a look at a brand new power station release from Anker Solix. And this is the F3000. Now this kind of sits right in between the F2000 and the F3800, although this does not output 240 volt split phase. So it is a 120 volt output unit, although you can actually parallel this with another F3000 and get 240 volt split phase with their whatever they call their parallel hub. But so you can do that, but it requires 2 units. But by itself, this is a beast. So this is rated for 3,072 watt hours. It does have battery expansion capability. As you can see here, it's got a TT30 or RV30 120 volt plug. And this will give you the full 30 amps because this is a 3,600 watt output AC pure sine wave inverter. Now you can get up to 2,400 watts out of the 3-prong outlets because these are 20 amps, but you can get the full 3,600 watts output from the TT30 port here. And then over here, it's got a standard 12 volt, 10 amp car socket. It's got what I believe is I'll have to double check myself on that, but 20 amp output Anderson connector there for DC outputs, which is nice. It's got a couple of PD100 Type C ports and a couple of 18 watt quick charge Type A USB ports, and typical display and a nice little LED light bar on top, which is nice if you're using this in an emergency backup situation where you need a little room lighting just to get you by. And then it does have some roller wheels because this thing does weigh in, I think, at something like 91.5 pounds, I believe. And it's got a really nice quality telescopic sort of suitcase style handle there to help you wheel this thing around because, like I said, it is a beast. Let me show you what's on the other side over here. These are mostly the outputs and the inputs over here on the left side. So let's take a look. All right, now on this left side on the top, we have got a little breaker reset, and then in the middle, we've got our AC connector for AC charging. Now you may look at that and go, hey, that doesn't look like a normal AC charging connector. And you're right, they actually have a 120 volt standard 3-prong AC charging cable with this sort of proprietary style connector right here. And the reason they've done it this way is because this needs to be able to handle both 120 volt charging at 1800 watts, which is what you get with the standard kind of 15 amp wall circuit, 3-prong outlet kind of a thing. And then you also get the capability of charging this with a 30 amp TT30 connector, like this guy right here, and it uses the same connector. And that's why they're using this proprietary connector here, so that you can switch between 1800 watts and 3600 watt charging, which is pretty cool. And we're going to test that out, make sure it works. And then underneath here, we've got a battery expansion port, which again looks like a fairly proprietary type connector. And then it looks like the same type connector over here, but this is also used for paralleling a second F3000 if you want to get that 240 volt split phase configuration. And that's where you would do that. Now on the back of the unit here, we've got a couple of solar inputs. One you will recognize as a standard XT60 port, and that'll let you put in up to 800 watts of solar with a voltage range of 11 to 60 volts max with a 17 amp cap. Now this other guy right here actually requires their kind of proprietary solar connection. This is their high input or high charging, fast charging solar input. So it's basically this connector with a couple of MC4s. But this one will allow you to put in up to 1600 watts of solar. And the voltage range is down to 11 volts all the way up to 165 volts, which gives you a lot of options, and then a max of 17 amps. And that might be very handy because you can put up to 3,072 watt hour battery expansions on this thing, giving you well over 12,000 watt hours or 12 kilowatt hours of total battery capacity. So obviously if you're going to max this thing out with battery capacity expansions and you happen to want to rely primarily on solar for recharging, you're going to want as much solar as you can possibly feed into this thing. So you can actually use both of these ports together. The total, you will get 2,400 watts of solar input on this unit. And not coincidentally, I'm sure, if you were to max this thing out at the full 2,400 watts of solar, if you use the multiplier of 5, which is somewhere, I think 5 is a little bit on the optimistic side, but 4.5 to 5 is a multiplier. If you multiply that by 2,400 watts of solar, that would allow you to get about 12,000 watt hours of charge capacity in a full day of good sun conditions. So that is just enough solar input to allow you to fully top this thing off, even if you have all 3 expansion batteries attached in a full day of good sky and sun conditions. So Anker Solix is positioning this as a portable power station that can also sit in that practical home backup power space. And so if you're just using a single one, remember you're getting only 120 volts, but 3,600 watts. But if you put 2 of these in parallel with their double voltage hub, that'll give you 240 volt split phase at up to 7,200 watts of continuous rated output. Now we don't have a second one, so we're not going to be able to test that functionality, but we are going to push this thing to its max and find out how well it functions when you're really pushing that 3,600 watts total continuous output from the load. And also, by the way, if you are charging this at 3,600 watts, you can put a 3,600 watt load on this, apparently, and it'll pass through all of that 3,600 watt power. And the reason why that's interesting is most power stations will not give you their full rated output for that UPS pass-through capability. They give you some subset or fraction of that, usually something like 50 or 60% or something like that. So this one gives you all of it, which is pretty handy. So we're going to test that and see how it works. All right, so enough talk. Let's start running this thing through the paces and see how well it stacks up. All right, let's do an AC discharge capacity test on this beast. Find out how many usable watt hours we can actually get through the AC inverter. And I do have this thing fully topped off, as you can see there at 100%. All right, got this zeroed out. We're pulling a full 120 volts, so that's excellent. All right, let me plug a load into this. And we're gonna try to run this beast all the way down. Here we go. And we'll just kind of keep our eye on that. And there we go. So we are pulling just about 564 watts. And we'll see what we end up with. We're gonna be counting up the watt hours right here. We'll see where we end up. So check back in the morning probably, well, or maybe later today. The timer here, the estimate says about 5 hours. So we'll see when we get back how we did. All right, our AC discharge capacity test looks like it's done. We are kind of flashing there at 1%. So let me plug the meter in and see what we ended up with. We got 2,730 watt hours. Now that's out of a rated 3,072. So that is an above average 88.9% of rated capacity that is actually usable for this F3000 through the AC inverter. So very solid numbers on the AC usable capacity. So let me get this thing charged back up and we will do it again through the DC ports and see how we do. All right, while we're charging this thing back up, I've got this set with the standard charging cable and we're charging it just below 1,800 watts. I'm gonna try putting some power in through the DC ports in the back, and we're gonna find out if this thing will dual charge AC and DC at the same time. So we'll know that if this number suddenly starts increasing. So let's give that a try and see what happens. And we are steadily rising. So I imagine we're gonna add another 400 watts or so. I don't remember exactly what I got my DC input set to. Let's just see where we cap out. This will not be reflective of the actual cap, which is probably 3,600 watts total. But as you can see, we can definitely charge via AC and DC. So if you have just a 15 amp circuit that you can charge from, but you also have solar, well, you can charge both at the same time. And that just reduced my recharge time to an hour and a half. So that's pretty cool. All right, we've got this F3000 fully topped off again at 100%. Let's go ahead and enable the DC outputs here. And let's see, we are reading 13.36 volts. We're going to try to pull a full 10 amps for this painfully long DC usable capacity discharge test. And I say painfully long because at over 3,000 watt hours, this is going to take a long time. So let's get this thing cooking here. And you can see under load, we have dropped down to 12.4 volts. That's a pretty respectable voltage coming out of that 12 volt port. And this is estimating 20 hours at that 132 watt discharge rate. So that will have an impact on our usable capacity. How much of an impact? Well, we'll find out in about 20 hours. All right, 22 hours and 39 minutes later, our DC discharge test is finally done. And just to double check here, We're blinking at 1%. Now, if I zoom in here on the battery tester for you, we can see that out of a rated 3,072 watt hours, we netted 2,656.8 watt hours. And that's actually a surprisingly good number. That is somewhere in about 86%, maybe 86.4% of rated capacity. So it's slightly above average number, and which is surprising because of the the duration of this test. So, I mean, almost 23 hours this thing ran. All right, I am recharging this F3000 here using that proprietary 120 volt AC cable. And as you can see, the current charge rate is 1,668 watts. We're at 2%. It's estimating 2 hours at this particular charge rate using this method. But there are faster methods. If you're using the standard AC charging cable here, which again has this proprietary connector on one end, and then your typical 3-prong connector on the other end, you're limited to about 1,800 watts. And this is about a 6-foot cable. And I point that out because this is another option. You can actually charge this thing using a TT30 connector, but notice this cable is quite a bit shorter. In fact, this is only about 30 inches long, 29 or 30 inches long max. So you got to keep that in mind. What this is designed to be able to do is to connect this cable here to the side. All right, and then you have to have something nearby. So you could either use an appropriate extension cable for 30 amps, but if you happen to have a gas generator or a power station with a TT30 on it that can output the full 3,600 watts, well, you can charge this thing at 3,600 watts. And in fact, this will actually pass through 3,600 watts. And that's actually a valuable use case. So what this is designed to do is really for powering an RV directly through there, or through a manual transfer switch connection from this TT30 out to the manual transfer switch. But let's try it out. And you can see we're getting 3,566 watts. And I can hear the fan starting to ramp up on the power source. This guy is still virtually silent, which is really impressive. But now, so I'm already at 20% state of charge, right? So from here, I'm able to fully charge from 20 to 100% in less than an hour. But that is a really cool feature. All right, let's do some load testing on this F3000. I have got this TT30 port here connected via a long cable back to my manual transfer switch. I'll put a little picture up there so you can see how that connection is made. But anyway, it's working just fine. It's actually powering my entire barn right now. I don't have a bunch of stuff turned on as of yet, but I'm about to start adding some load. Currently, we're only pulling just under 1,200 watts. So let's go ahead and start adding some load, and we'll see where we end up. See if we can get it to that 3,600 watts continuous rated output, and then we'll see if it'll sustain that for at least 10 full minutes. I got a bunch of stuff plugged in. I'm gonna start my shop vac, which should add some pretty good load. All right, so we have just topped 3,000. So you can see it did actually allow the shop vac, which pulls about 800 or 900 watts by itself continuous, but also has a significant surge. So even though we were already at somewhere around 2,000 watts, a little over 2,000 watts, it did also handle that inrush current surge from the shop vac. So we're sitting pretty good right now. All right, let me start ratcheting up the load. All right, 3611. All right, let's go ahead and start the timer. All right, 10 minutes, absolutely no problem. And with that shop vac running in the background, you really can't tell, but this thing has actually been whisper quiet. Let me turn off that shop vac and just kind of show you what I'm talking about. So even after running full out for 10 minutes, this thing is still not even really breaking 50 decibels. So that is extremely impressive quiet operation out of this F3000. All right, I'm gonna turn on that shop vac again, and we're gonna dial up this thing and see if we can find the tripping point. All right, so we're currently sitting at 3545. Let me go ahead and try to take this up another 100 watts. So we're at 3641. Let's go ahead and start a timer here so we can kind of see how long it's going to keep running. So we've actually been running already for at least 30 seconds over that 3600 watt threshold. We take it up to a little more and see if we can get it to trip here soon. All right, now we're 137 watts overrated. I'm not showing any indication on the screen that we're impending an overload, although I have to believe we got to be getting close. All right, it's been a full minute at well over that rated 3600, about 140 watts more. Let's go ahead and add another 100 watts and see if this trips it. I can hear it struggling. Apparently it's throttling us because it actually dropped. And I'll bet you if I put a voltmeter up there, yeah, we're down to 104 volts. I need to open the app and see if I can change that setting. All right, so apparently it will throttle you, and I don't see where I can change that in the app. Let me back off that load a bit and see if the voltage comes back up. Yeah, I can hear it ramping back up. And there we're back to 120 volts. Okay, so turn that shop back off so we can talk about this. So yeah, when you get well over 3600 watts load, it will start dropping the voltage on you. And there's a bunch of different names for that kind of voltage throttling feature to prevent overload trip. At some point, this definitely will trip. I have no doubts about that. Yeah, so you just want to be aware of that. If you're really going to push this past that 3600 watts continuous load in any way, you want to make sure that none of the loads you are applying are complex electronics like TVs or refrigerators, for example. So yeah, just something to be aware of, but it will definitely handle that 3600 watt continuous and then some with a little bit of overhead. So it definitely passes the inverter load test. All right, let's talk about the pass-through capabilities of this F3000. If I zoom in on the display here, you can see we are charging at just a hair under 3600 watts. And I'm actually using a gas generator, which you can hear. So let me go over there and show you what I'm kind of doing there. These gas generators are pretty loud, and got it outside because of the fumes and the noise. So I'm going to just kind of keep the door cracked here so hopefully you can still hear me. I've got through this cable on the front, the TT30 going into my manual transfer switch in the barn. So I'm charging at a very fast rate here, and we are only serving a load, which is being passed through, by the way, of 186 watts. We're going to see if we can crank that up. I'm going to start switching additional loads over, and we'll see where we end up. All right, that got us about 2,000 watts. All right, so we're pretty close to 3,600 watts output and 3,600 watts input. So right, just a hair over 3,500 watts in both cases. And it's estimating 45.5 days remaining runtime. And that is because we are basically using all of the pass-through power to power the loads instead of charging the battery. So if I were to reduce the load, for example, now we've got a spare 1,000 watts that we're not passing through on a load that we can use to charge the battery. And so now we're getting an estimate of 1.4 hours on that recharge rate. So pass-through power on this thing definitely works. Let me go shut off the generator, and we're going to sort of reproduce a power outage and see how this behaves. All right, I saw a momentary flash there, and now we are no longer getting power in, we're only putting power out. All right, let me go switch off some of this noise so that we can have a quick conversation. All right, so I don't know if you can see this, but I'm still running all the lights and stuff in the barn here. I've got 1,747 watt load being served by the F3000, and I've got the mic right here. You can't even hear this thing. It is virtually silent. This has got to be one of the quietest power stations, if not the quietest power station that I've tested so far. So pretty shockingly quiet, I have to admit. But one of the advantages of being able to pass through 3,600 watts and charge at 3,600 watts rather than just 1,800 watts. So if you're using a gas generator to do that, the longer you have to have that gas generator run, the more fuel you're burning, the more fumes are being generated, the more noise you're creating and all that sort of thing. So if you're using a gas generator to supplement power and charge to your power station, having something that can charge at 3,600 watts means that you don't have to run that generator for nearly as long. So you're saving fuel, you're saving noise, you're saving fumes. So I really like the ability to charge at 3600 watts and to be able to pass through that charge, because let's say in a power outage situation where I'm using this as home backup power, I'm not having to worry so much about how much of that load is coming online at one time. This thing can handle the full 3600 watts without tripping that overload. So on the pass-through test, the F3000 passes with flying colors. Oh, and by the way, since we're talking about the inverter in this thing, I did do a no-load draw test, which I completed just before I started this particular test. And I ran this for a full 24 hours with the AC inverter turned on. I turned off all the eco mode and the smart management and all that so that it wouldn't time out and shut off the inverter. And after a full 24 hours, it went from 100% down to 77%. So that comes out to 0.96% per hour of total capacity that you lose if you forget and leave the inverter on. And so if we divide that 0.96% into the rated 3072 watt hours, we get approximately slightly less than 30 watts of continuous draw from this inverter, which is actually not bad for a 3600 watt inverter. Very competitive, might even be a little better than average. All right, while we're at it here, let's go ahead and do a noise test on the AC inverter and find out how noisy or clean the AC output is from this F3000. And to do that, we can get a nice audible indicator feedback here from this old guitar amp. So I've got the guitar amp currently plugged into grid power, and we're gonna get a baseline to see how it sounds from grid power, which is known to be relatively clean. So here we go, here's our baseline test. All right, so now you know what it sounds like when it's clean. Let me go ahead and transfer the cord. As you can see, the grounding pin has actually been snipped off on this thing. Not by me, but by somebody else. Let's go ahead and turn the AC inverter on, and let's see how it sounds now that we're plugged into the F3000. All right, definitely an audible difference. So I've definitely heard noisier AC inverters than that, but that is something that might give me pause to use something like this as a remote power source for a PA system or a guitar amp or a ham radio or something like that. Okay, taking a quick flyby on the Anker Solix mobile app. As you can see on the main landing page, it's got all the usual information and controls for both the AC and the DC side, including the USB ports. So I can say turn on the AC outputs remotely. And then when I do that, you'll notice that there's a button with a little timer icon that appears to the left of that on and off button. And if I click on that, this feature actually lets me set up a timer. And that lets me do that by either picking one of these presets or by selecting that customize option and defining a specific timer of my choosing, after which the unit will turn off the AC power. And that's pretty handy because most power stations only give you the option to enable or disable just the shutdown timeouts. And those really only apply when there's a very low load, say like 20 watts or less. So this is pretty cool that you have this option. And if you open up the settings page by clicking on that little bolt icon in the upper right hand corner, you'll see I've got a number of other options there as well. So you can set the specific recharge power for the standard charging cable. And this is pretty handy when you're not in a hurry to charge the unit. Maybe you want to charge a little more slowly to minimize the stress on the battery cells, increase that overall long-term service life a little bit. Or maybe you've already got some loads running on that particular charging circuit, so you don't want to try to pull the full 1800 watts to avoid tripping that breaker. And then you've got similar options for a couple of the other optional charging cables, including that 30 amp charging cable that we talked about, and then also an adapter cable that lets you fast charge from a level 2 EV charger. So you can specify the actual charging rate for both of those as well. Now, if we back out one level, there's also a separate power saving mode for both DC and for AC. And on the DC side, when you enable this, it will automatically power down the DC ports after 5 consecutive hours if the load is less than 3 watts, which is pretty appropriate for DC. And then on the AC side, enabling that option will automatically power down the AC outputs if the AC load is less than 20 watts for 15 minutes. And then there's an option to set or disable the master shutdown timeout, and then the display screen timeouts, control brightness, set your temperature units, all the normal things. And then you can also update firmware here as needed from the mobile app as well. So that's something that I've actually done twice now during this pre-release period, and Anker Solix continues to make improvements. So yeah, all of the basics and a couple of nice functional surprises in this Anker Solix mobile app. And by the way, the F3000 did run my DC fridge through the AC inverter for several days, even with that smart AC output mode enabled. And that means that you shouldn't really have to worry about the F3000 shutting itself down on a pretty intermittent load like a small camping fridge. And then I did also confirm that the F3000 will run virtually every power tool that I own, including my 12-inch compound miter saw, which has a pretty big inrush current. So if that's a use case that you'd want to be able to accommodate, there should be no problems there. And so I'd say that with the F3000, there's really only one specific use case that we found that it's not particularly well suited for, given that it does seem to introduce a fairly significant amount of audible noise when you're powering things like guitar amps and PA systems and things like that. So not the best fit for that specific kind of thing. But that aside, I do find that the F3000 is an extremely well-built and versatile high-capacity power station. And the ability to pass through that full 3,600 watts of AC input to your critical circuits is extremely handy. And that 2,400 watt total solar input capacity is also a very solid spec, especially given the ability to expand this unit up to 12 kilowatt hours with a single F3000, or 24 kilowatt hours and 4,800 watts of solar if you put two F3000s together in a 240 split phase mode. And then to be able to output as much power as it does and also be able to charge as fast as it does with nearly silent operation is really just plain impressive. Now, I'm sure that in some particularly hot environments, those fans are going to have to come on at some point, and I'm sure you might be able to hear them, but so far, I've yet to witness that myself. It's been completely silent. So definitely one of the quietest high capacity options I think you can get right now. All right, let's finally get to the question of price and warranty. And regarding the warranty, while I couldn't confirm this during the pre-release period, every other power station that Anker Solix sells has a 5-year warranty. So I'm pretty confident in assuming that the same 5-year warranty is going to apply to this F3000 as well. And regarding the price, well, again, unfortunately, since the F3000 is still, at least at the time that I'm releasing this video, in a pre-release status, I don't have the specific pricing information quite yet. But what I can tell you is that during this early bird pre-order period, which is going to run between now and June 24th, I believe, they are offering a $1,000 off coupon code if you jump over to the website and sign up with your email address prior to June 24th. Oh, and another thing you probably want to be aware of, because this changes the calculus pretty significantly, is that since the unit does have over 3,000 watt hours of capacity, it should qualify for that 30% residential clean energy tax credit, at least through the end of this year, 2025. But after that, though, it's anyone's guess whether it'll still be in place, because some members of Congress have proposed a bill that could eliminate this tax credit after 2025 if it's finally passed. But the point is that if you can take advantage of that $1,000 off early bird coupon and a 30% clean energy tax credit, the F3000 should be a heck of a deal at whatever the likely release pricing ends up being. And per usual, you'll find a link below to Anker Solix's landing page for the F3000 if you're interested in jumping over there and checking it out in more detail. Okay, I think that's a wrap on this one. Hopefully you found something helpful or informative in the video. And if you did, I'd very much appreciate it if you'd be so kind as to click that like button down below there for me. And if you do have any lingering questions about the F3000 still, please leave those in the comments section below, and I will do my best to try and answer those questions for you. I do thank you for spending some of your valuable time with me today, and I do hope you'll consider coming back and joining me for the next one. Until then, have fun out there.